We need to write these mixed numbers as decimals. First, we have 1 and 2 tenths. That's 1.2 because the digit before the decimal point is the ones digit, so tells us how many wholes we have, and the digit after the decimal point is the tenths digit, and we have 2 tenths. Now, 1 and 2 hundredths is written as 1.02. That's because the second digit after the decimal point is the hundredths digit, and we have 2 hundredths. That means we need a 0 in our tenths to make it clear that we're writing the 2 in the hundredths place value column. Now, 1 and 2 thousandths is 1.002. That's because the third digit after the decimal point is the thousandths digit, and we need to show that we have 2 thousandths, so we need zeros in our tenths and hundredths. Notice the denominator of 10 tells us that there will be one digit after the decimal point because the first decimal place value is the tenths. The denominator of 100 tells us that there will be 2 digits because the second decimal place value is the hundredths. And when we have a denominator of 1,000, we need 3 digits after the decimal point because the third decimal place value is the thousandths. So now we have 4 and 32 hundredths. The denominator of 100 tells us that we can only use 2 digits after the decimal point. So that's 4.32. The 3 gets pushed over into the tenths because the denominator of 1,000 tells us that we can't go beyond the thousandths place value, so we can only have 2 digits after the decimal point. Now, 5 and 32 thousandths. The denominator of 1,000 tells us that this time we can only have 3 digits after the decimal point. So we write 5 and 32 thousandths as 5.032 because then we have 3 digits after the decimal point, so we're not going beyond our thousandths place value, but the 3 gets pushed over into the hundredths place. Finally, we have 6 and 321 thousandths. That's 6.321. The denominator of 1,000 tells us that we can't go beyond the thousandths place value, so we can only have 3 digits after the decimal point. That means the 2 gets pushed over into the hundredths, and the 3 gets pushed all the way over into the tenths. So notice, when the denominator is 10, that's 1 0, so when we write the number, we have 1 digit after the decimal point. When we have a denominator of 100, that's 2 zeros, so we have 2 digits after the decimal point. And when we have a denominator of 1,000, that's 3 zeros, so we have 3 digits after the decimal point. Now let's take a closer look at these last 2 questions. We had 5 and 32 thousandths. That's 5.032. If we break down this number into its place values, we have 5 wholes, no tenths, 3 hundredths, and 2 thousandths. So how does that give us 5 and 32 thousandths? Well, the 5 stays the same, but 3 hundredths is equivalent to 30 thousandths. That's because we use multiplication to find equivalent fractions. 100 times 10 is 1,000, and what we do to the denominator, we do to the numerator as well, and 3 times 10 is 30. So we can add the 2 thousandths to that, so our whole number stays the same. We have a common denominator of 1,000, so that stays the same in our mixed number, and 30 plus 2 is 32. So that's why 5 and 32 thousandths is equal to 5.032. It's because 30 thousandths is the same as 3 hundredths. Then we had 6 and 321 thousandths, and that was equal to 6.321. If we break down this number by its place values, we have 6 ones, 3 tenths, 2 hundredths, and 1 thousandth. The 6 can stay the same, But instead of 3/10, we can write 300 thousandths, because 10 times 100 is 1,000, and if we do the same to the numerator, 3 times 100 is 300. Then, instead of adding 2 hundredths, we can add 20 thousandths. That's equivalent because 100 times 10 is 1,000 and 2 times 10 is 20. And then we add 1 thousandth. So the 6 stays the same. We have a common denominator of 1,000, and 300 plus 20 plus 1 is 321. So that's why 6 and 321 thousandths can be written as 6.321. It's because 300 thousandths is the same as 3/10, 20 thousandths is the same as 2 hundredths, and then putting that together with the 1,000th gives us 6.321. Let's just have one more look at this question, 5 and 32 thousandths. That's 5.032, because remember, 10 thousandths can be exchanged for 1/100th, and when we do that with 30 of our thousandths, we have 5 ones still, but now we have 3 hundredths and 2 thousandths, so 5.032.